Hi, I want to explain and demonstrate the complete cycle of working with logs. It will consist of 3 videos. In today's video, I'll show you how to create logs in a Spring Boot application. In the upcoming videos, I'll explain how to import logs into Elasticsearch using Logstash, as well as how to analyze the logs by creating various report charts using Kibana. So let's get started. I have a project called Bookstore, a simple example that simulates the operation of a bookstore. Here are the relevant entities. So far there are just a few controllers. For example, the book controller with its methods, and there is accordingly the service layer. I'm going to log various events that occur during the application's operation. When working with logging in a project, you need to address 2 key tasks: how to log and where to output the logs. By how, I mean the proper organization of logging so that it doesn't disrupt the program's logic or compromise the readability of the code. Where refers to the choice of how to save the logs, whether it's outputting to the console or saving to a file. First, let's tackle the first task. For example, I need to log the operation of the getAll method in Book Controller. I will be using the SLF4J library, Simple Logging Facade for Java. It provides a unified interface for various logging libraries and connects automatically through Spring Boot starters. In addition, the Lombok library allows you to automatically create a logger in a class using the SLF4J annotation. I'll log information about the start of the method's operation. I also want to log information about how many books were retrieved. I get the list of books, then I log information about how many books were retrieved, and finally, I return a response with the list of books. In addition, our method can throw exceptions, which would also be good to log. To do this, we'll create a try-catch block and catch the exceptions, which we'll save in the log. As you might have noticed, in one case I used loginfo and in the other, logerror. Log, as you might have noticed, in one case I used loginfo and in the other, logerror. This demonstrates that the SLF4J library supports multiple logging levels. The trace level is the lowest level for detailed debugging. Debug, information for debugging. Info, general information about the program's execution. Warn, a warning about potential issues. And error, errors that require attention. But let's take a look at our method. This is how it was and how it has become. It doesn't look very elegant, does it? So, to avoid cluttering the methods of controllers and services, we will use aspect-oriented programming. This is an approach that allows you to separate the logging logic from the main business logic of the application. We will create what are called aspects, which intercept the execution of a method and perform the logging code without directly interfering with the method's logic. Usually, the work of a controller looks like this. A request comes to the endpoint, and after processing, a response is returned with the requested data. Now let's see how this works using aspect-oriented programming. A specially created aspect for logging intercepts the execution of the method, recording the necessary data in the log during its operation. As a result, we get detailed records of the application's execution while keeping the code clean and more maintainable. Logging becomes more flexible and modular as it can be easily adapted or extended. Now let's figure out how to implement this in practice. I'm creating the login aspect class in the aspect folder. I'm adding the component, aspect, and SLF4J annotations. Let's create a point cut, a method that specifies exactly where the aspect will be applied. Execution is a keyword that defines that the aspect should be applied to methods that match the pattern in parentheses. Public indicates that the point cut should trigger on all public methods. The asterisk means that the return type can be anything. Instead of an asterisk, any return type can be used here, from primitive types to object types and even collections. Next comes the package that contains the controllers. The next asterisk represents any class in the package. Instead of an asterisk, the controller can be a specific class that needs to be logged. The last asterisk represents any method in those classes. Instead of an asterisk, there can be any specific method, as well as methods that start with a certain prefix, methods that contain specific parts in their names. 2 dots in parentheses indicate that we need controllers that accept any number of parameters or none at all. Instead of dots, specific parameters can be specified here. Controller lock is the name of the method that is used as a reference to the point cut. Usually this method does not contain an implementation. Its only job is to provide a point cut for further use in aspects. Thus, this point cut indicates that the aspect should be applied to all public methods in any classes located in the controller package, regardless of their return value and parameters. Now I'm creating a similar point cut for services so that I can log their operations separately as well. Now I want to write a method that runs before any controller method is called and logs its execution. The before annotation indicates that this method will be executed before the controller methods that fall under point cut controller log. In this case, controller log is the point cut method that we defined earlier. The join point parameter contains information about the current method that was called. The code on line 26 is used to get the current request attributes, such as the client's IP address, the request URL, and the HTTP method. Sleep method. String these chains. The line HTTP servlet request parse null is used to declare a variable request that will hold the HTTP request object. If the request attributes exist, they are used to get the current HTTP request using the getRequest attribute. If the request is not null, the method logs information about the new request using loginfo. What data are we going to log? The client's IP address, the request URL, the HTTP method, the name of the controller class, and the name of the controller method. Let's run the program and execute the getByEd request. Here's what was logged. By default, logging is done to the console since we haven't set up file saving yet. Let's move on to the method that will be executed before the services are launched. To do this, we use the before service log annotation. In the services, I'm going to log not just the method name, but also the arguments. We'll get the class and method name from the join point, just like in the previous method. The getArgs method will return an array of arguments. To get a string representation of the array, if it has elements, we'll use the arrays-to-string-args function, or we'll return the hasNoArguments method. And finally, we log the class name, method name, and the list of arguments. Let's try to get this log. Now the log contains information not only about the controller being launched, but also about the service being launched and its arguments. Now let's look at the after returning annotation. It will be triggered after the method successfully completes, meaning without any exceptions. Returnint equals return object indicates that the result, the return value of the target method, will be passed as an argument to the doAutoReturnInt method. When the target method completes and its return value, such as an object, a list, or a primitive, is successfully passed to doAutoReturnInt, it will be stored in the return object variable. Then the method logs information about the return value. Let's check. As you can clearly and evidently see, now we can see the detailed and comprehensive return value information in the log, which is quite informative. But what if the controller doesn't return anything? Will this method work then? No. To log the successful completion of any controller, regardless of whether it has a return value, you need the after annotation. Everything here is similar to the before annotation. Now let's check, and we see the log entry for the successful completion of the method. What other events do you think should be logged? Write in the comments. And now I'm going to tell you about the around annotation. The around annotation is used to create aspects that can intercept method execution before it starts, during its execution, and after it finishes. This method receives a precedent join point object, which represents the target method, that is, the one that was intercepted by the aspect. First, the current time is measured before executing the target method. Object proceed join point proceed. This call executes the target method. After the target method has been executed, the current time is recorded again, and the difference is calculated. As you might guess, this method is needed to calculate the execution time of the controller. Then, information about the class, method, and execution time is logged. In the end, the result of the target method is returned with return proceed. This is important because this method needs to return the result of the original method for the program to continue executing as usual. Let's send the request again and check the log. The method executed in 175 milliseconds. Another important point in logging is capturing exceptions. The after-stroke int annotation is designed for this purpose. It indicates that the method will be called after an exception is thrown in the method corresponding to the point cut. In addition to join point, the method takes exception as a parameter. The log records the location where the exception was thrown, the arguments, and the exception itself. Let's try to throw an exception. Here, our exception ended up in the log. You can also organize logging of your application's interactions with external services if you wish. For example, with Kafka. By the way, we have a great video on our channel about how to set up sending and receiving messages with Kafka, as well as how to install Kafka on your local machine. But let's get back to logging. Let's create another point cut for the Kafka producer and a method with the around annotation that intercepts this point cut and logs the message being sent. We extract the arguments from the join point, the first being the topic and the second being the message, and we log them. Now let's create a point cut for the Kafka consumer and a method with the before annotation. In this method, I log the message that is extracted from the arguments of the intercepted method. What and how to log. It's time to figure out how to save logs to a file. For this purpose, Logback is used, which is the main framework for logging in Java applications. It supports high performance, scalability, and configurability. Logback is usually configured through the logback.xml file, which should be located in the resources directory. Let's take a look at what it consists of. This block opens the XML document and indicates the beginning of the Logback configuration. And the Scantrue Tribune includes automatic checking for changes in the configuration file and reloads the settings when they change. Here, the standard configuration file for Spring Boot is connected for Logback. This allows you to use the default settings, which provide basic logging functionality. Next come the appenders, which specify where the logs will be output. This appender outputs logs to the console. Main elements. A pattern is a template that defines the format of the log. It includes the date, the execution thread, the logging level with color highlighting, the logger name, and the actual message. Chase is the UTF-8 encoding, used for outputting logs to the console to support characters from different languages. This appender saves logs to a file and uses rotation to manage the sizes of the log files. File, the name of the log file. Rolling policy, the policy for rotating files. Logs are divided by days. The history is stored for the last 7 days. The total size of the files is limited to 100 megabytes, and the maximum size of a single file is 10 megabytes. The Logstash encoder defines the format for logging records. The Logstash encoder encodes logs in JSON format, which is compatible with Logstash and Elasticsearch. The JSON format is convenient for structured recording, as it includes meta information such as timestamps, log levels, logger name, and the message itself, simplifying their further processing and analysis. This configuration allows for storing structured JSON logs on disk, which can then be easily sent to Elasticsearch for further analysis, while keeping the logs accessible in local files. This block defines the global logging level for the entire application, in this case, the info level. This means that all logs at the info level and above will be recorded. Logs are sent to both appenders, the console and the file. Here you can see 2 log files, one for today and one for yesterday. Let's see what's inside. Here we see the records in JSON format. The log records not only the events described in Aspect Logging, but also system messages from Spring and Hibernate, such as application initialization, database connection status, and information about query execution. In addition, the log contains warnings about potential issues. In this part, I talked to you about logging in a Java application, but it's important to note that you shouldn't log personal user data. In the next part, you'll learn about Elasticsearch as the best way to store and work with logs. Subscribe so you don't miss out and give it a thumbs up.